Welcome back. This is A level Computer Science 9618 paper 2, and this is part 8, and this is chapter 4 of paper 2, which is software development. And now let's begin with development life cycles. So what is a development life cycles? It's a developing a program which is set in 5 stages. Number 1 is analysis, number 2 design, number 3 coding, number 4 testing, and number 5 maintenance. Analysis is when you are taking information from the customer, you are making interviews, you are taking information, you are gathering requirements from the customers. Okay, so process of investigation leading to a specification what a program is required to do. You are gathering requirement from a customer, which eventually you will make a requirement specification, and the requirement specification is a proper documentation of what the program should do. It's more like you're taking in requirements from a customer that what the program should do, how should we made it, what the program should really do, what you want, what are the functionalities that you want in the program. Okay, then design, use the program specification to show how the program should be developed. Use the program to show how the program should be developed. Formally document using structure charts. You are documented, you're using structure charts, state transition diagrams, and pseudocode to make documentation. Formally document it. Okay, using the specific requirements specification that how the program should be developed, and you are documenting it using structure charts, state transition diagram, and pseudocode. Coding, you are writing the program. Testing, the testing of the program to make sure that it works under all conditions. You are testing the program, right, that it doesn't show any errors. Maintenance is when you are dealing with problems that arise during use, bug or something like that, or you are improving the functionality of the program. So that's where maintenance comes in. Now we have come to 3 different models, which is, first we will start with waterfall model, which is a sequential, it's a linear sequential development cycle where each stage is completed and sign off before the next stage is begun. It is sequential, so one stage is complete, then it goes to the second. It doesn't skip. Okay, it goes in sequential. It is well documented, well planned. It's more like a plan driven model, so it's well documented, which means there's low customer involvement. There's no need for customer, since we have already know what to do. Low customer involvement for gathering requirements and specification. Difficult to change the requirement. Obviously, after you have gone through gone to the last stage, it is very difficult to change the requirements, okay, at a later stage. Not suitable for program where the requirement could be subject to change. Okay, so yeah, it's not suitable for those programs where the requirement could be subject to change. So waterfall model is good for smaller projects. It's good for smaller projects, waterfall model. Now the iterative model is when you are doing incremental development as a program lifecycle is repeated. So you are going through this over and over again. You are making versions. Okay, for example, you are in Android, in Google Play Store, you have so many apps, and when you download the app and you use it for some time, and then you get the update, then you try to update, and then the program is the app is updated. So that's called, you are that's more like iterative model, incremental development. You get the first version, you show it to the customer, and then you're making the next version. Then after that, you make the first version, then you are showing to the customer, you're getting some feedback from the customer at what should be, what should not be, and then you make the second version through that. Okay, so incremental development is the program as a program development lifecycle is repeated, having series of versions, giving functionality to the next version. Having series of version 1, then you show it to the customer, and then version 2 develop, having more features, then version 1, version 3, version 4, like that. Okay, so you are going through this life cycle, these stages. You're making so many versions repeatedly until it's complete, until you got a complete picture. You got the program that you want. Okay, so higher customer involvement. There's high customer involvement since there's less documentation, which means that you need customer involvement, you need their feedback as part of the system that can be shown to the customer after every iteration, after showing versions to the customer and taking their feedback. So it is easier to test and debug smaller programs. Whole system need to be defined at start so that it can be broken down into pieces to be developed at each iteration. This is suitable for larger projects and not suitable for short simpler projects. Okay, so if you have larger project, you can just break it down, and yeah, you can just do it. You broke it down and you can debug smaller programs and easy to test. Okay, whole system need to be defined at start so it can be broken down into pieces to be developed at each iteration. Okay, so that's iterative model. This is the diagram. First waterfall, extended waterfall, further extended waterfall, which means you're going to the first waterfall, you get the version 1, you show it to the customer, you get the feedback, then you go to the extended waterfall, you get the second version 2, you show it to the customer gives you the feedback, then you come to the next one, it keeps on going. These stages are repeated as necessary to develop the program. Okay, now the next one is rapid application development, RAD. It developed different parts of the requirement in parallel using prototyping. So the concept of prototyping is being used here. Definitely we use prototype in RAD. Prototype. What is a prototype? Prototype is something that you show it to the customer. It's more like a display of how the program would look like, how adding some of the features, you just show it to the customer. That's what you call it, a prototype. You're showing to the customer, you're giving the demo of that program, that how it would look like, how it will perform, where you will do this, where you do that. So that's prototyping. So that's a prototype. Okay, develop different parts of the requirement in parallel using prototyping to provide early user involvement in testing. There's high customer involvement in testing. Yeah, so when you are doing some tests, you will show it to the customer, you get some feedback from the customer, and yeah, you will just try to develop. So it's run in parallel for each part of the requirement, which means you have different teams for each stage: team 1, team 2, team 3. So runs in parallel for each part of the requirement using a number of different teams, suitable for complicated projects that need developing in a short time frame. You have a short amount of time to meet the evolving needs of a business. Okay, you have got short amount of time to complete the project. Reuse previously written code where possible. That's the advantage. Make use of automated code generation where possible. Higher customer involvement, as I have just told you before. You are showing prototype to the customer, you're getting feedback from the customer, as customer can use a prototype during development. Not suitable for short simple projects, it's used for bigger projects, and there's no little documentation in this model as well. Okay, so we have gone through these models. Now let's move on. Now we have come to the testing part. Let's start from here. Acceptance testing, the testing of a complete program to prove it to the customer that yeah boy, it works as required. Beta testing is when you are when the program is being tested by a group of users. The program is being used by a group of users before it is being released. Okay, so alpha testing. What is alpha testing? Testing by development team. Beta testing is testing by a group of users before it is released. Integration is when you are testing a whole system as a whole to also test that the program is working, all the modules are working together. So testing a program as a whole. Black box testing is when you are testing the input and output of the modules. White box testing is when you are testing the structure and the logic of every path through a program module. Subthreading is when you are using dummy modules for testing purposes. Walkthrough or dry run are both the same thing. It means that you are writing down pseudocode and you are using trace table to to test the program you're doing manually, you are writing down. Okay, and also you are using predefined test cases. So it involves working through a program from program module, writing pseudocode using trace table. Walkthrough is more like a formal version of dry run using predefined test cases. Okay, now we have normal data, abnormal data, extreme boundary data. Abnormal data is where the data that should be accepted. Abnormal is data should be rejected. Extreme boundary data are those that is on the limit of that accepted by a program. It's on the boundary that should be accepted. Maximum, minimum, you can call it. Then we have syntax error, logic error, and runtime error. Syntax error are errors in the grammar of a source program. Logic errors are the logic error in the logic of a program, that the program does not do what it's supposed to do. Then we have runtime errors. Error found in a program when it is executed. The program may halt unexpectedly or go into an infinite loop and need to be stopped by the proof work. Okay. Okay, now we have different maintenance. These are maintenance. Let's start with here. Perfective maintenance, the process of making improvement to the performance of a program. Focus on the evolution of requirement and feature that existing takes over the workboard, adding features that can enhance user experience, removing features that are not effective and functional. More like perfecting it. Okay, you're making improvement to the performance of a program. Then you have adaptive maintenance, the alteration of a program to perform new tasks. For example, working with voice command as well as keyboard entry, amending a program to enhance functionality or in response to specification changes. Okay, either to enhance functionality or to respond to specification changes, which is known as adaptive maintenance. Corrective maintenance is when you are correcting any error that appear during use. Correcting any errors, which means those runtime errors. When you are running the program and you got those runtime errors, those errors that are unexpectedly halted the program, or so you catch that error and you try to figure it out that where is this error is coming from, how to solve this, and you just do dry run and you solve that error. So it's more like catching those runtime errors, okay, when you're using it. And there you go, this is the end of this chapter 4, and this is the end of A level math computer science P2. Thank you so much for watching, and I'll see you guys in the next video.